that he helped us with. Yeah.
Who helped us? Who helped you? No, you didn't all pass anyway. No, you all passed. You didn't all do great.
Oh, yeah, I like that.
Yours? Either way. All right. Well, we're going to start something new today. And I wanted to show you something here. These, we're going to do the metric conversions today. We're going to talk about metric system. But before we get our stuff out, just wanted to show you. In red are all the countries that don't use the metric system. Alaska's not a separate country, by the way. That's part of the United States. Us. Anybody know what that is? Liberia. And Myanmar. Yeah. It used to be called Burma, but now it's Myanmar. So yeah, we have a lot of good company. We're the only 3 countries that don't use the metric system, just in case you're wondering. Now, I am not going to teach this. Obviously, I could be teaching the metric system just because if you ever go to anywhere else on the globe, you're going to need it, except Liberia and Myanmar. But anywhere else, you're going to kind of need to know it because all the signs are in, that and everything. But that's not the only reason I'm going to teach it to you. In science, even in these 3 backward countries, even here, everything we do in science is done with the metric system. So you'll never, ever measure in inches or in pounds or in quarts and ounces. Not in science. You will in home ec. You will if you go to the lumber shop, right? You go to the lumber store, you're going to pick up your 2x4. What does 2x4 stand for? 2 inches by 4 inches. You're going to measure your height when you go to the doctor's in feet. You're going to measure your weight in pounds. But in science, anywhere in science, you don't. Even in the United States, even here, everything we do has to be in grams and has to be in meters and all those other things. Okay? So I'm going to teach it to you. Now, some of you are probably saying, I already know how to do it. And you're right. Most of you do. I'm going to teach you how to convert. But don't get anything out yet. Not yet. Let me just show you something. Let's say I asked you, I bet you can do this without getting anything out. If I told you you had 5 kilometers, and I wanted you to convert that to meters. Okay? Raise your hand. What do you think? What do you think? Spencer?
5,000.
5,000 meters? You all agree that's what it would probably be? Okay. Now let me make it a little harder. What if I told you you had 5 decimeters, and I wanted you to go to hectometers. All right? Might be a little harder. What do you think? Anybody want to take a stab at it? Probably not going to get it right, but that's okay. See if you're at least going the right way. What do you think?
500?
Nope. For one thing, it's going the wrong way.
3,500.
3,500?
Well, additional 7 hecto.
No, hecto. No, that's one of the things about the metric system. That's a good point.
44, Mrs. Baker. 45, Mr. Bond. And 47, Mr. Costa. Students in those homerooms need to report to the auditorium at this time.
Wait, before you go.
Rooms 44,
Wait.
45,
Wait.
47. Thank you.
No. The one good thing about the metric system is it's always a factor of 10. And so it turns out if you're going to go from decimeters to hectometers, it would be 0.005. Okay, that's what you would get. Now, you guys get back your as quickly as you can. Hurry up. Because I am going to be giving you notes on this stuff. And I'm teaching you how to do it. Because as you can see, we're going to need a little help for that reason alone. But here's the best one. Okay, you ready? Hannah, before you go, I want you to convert 5 years to seconds in your head. Quick, come on, what is it? How many seconds are 5 years? Come on. Well, besides who cares? That's a good answer too. But besides who cares? We often do have to make conversions. Close that door, please. All right. Now, let me explain. Your method beforehand works for easy ones, and it works because you're just kind of like moving a decimal place, counting spaces, right? But you make 2 mistakes. One is, Spencer did it before, he said 500, I think, a second ago, or 50. you move it the wrong way, or you don't count the right number of spaces. Both of which, if I were to teach this to you, I could show you how to do this very easily, very quickly, the way you used to do it, just by counting spaces and moving it the right way. And you get just as many right, but I'm not going to do that. I'm going to teach it to you a whole different way, an entirely different way of doing this. All right, and you may say, well, why? Well, a couple of reasons. One, it will help us get the right answer for these, ones that are harder. But it will also be able to do things like this. You see, there are times when you have to make those kind of conversions, especially in science class. And so to make these kind of conversions where you have to go through multiple steps, you're going to need a system that doesn't just move a decimal place over, okay? So there's two reasons. You want to get the answer right, and you want to also be able to apply it to different areas. So let's do that. Let's start this here. Okay, metric conversions. Yeah, now we're doing it. Metric system conversions. The thing is, you're going to have to know this system, and we're going to apply it to everything we do in chemistry for the rest of the year. If I just wanted to teach you the metric system, I wouldn't teach it this way. I would teach it the way you originally learned it, but I don't. I want to teach you something beyond the metric system. I want to teach you something you're going to use in everyday life included, but especially in this class. All right? Basically, we're going to use something called conversion factors. You may or may not be familiar with this. Probably not. Although you do get a little bit of it in your math classes from middle school, a little bit maybe. It's a two-step procedure. The first step, a monkey could do it. What do you do first? Well, you're going to simply write down the given information. That's it. So if it says, I want you to convert 5 kilometers to meters, you simply write down 5 kilometers. Like I said, a monkey could do this. It's pretty easy. But the second step is the one that involves actually a little bit of thinking. It's not hard. You're simply going to multiply by a conversion factor. But that conversion factor contains 2 parts. You don't know what that conversion factor is, so let me explain what it is. It contains 2 parts. Every conversion factor is a fraction, basically. Every conversion factor is going to be a fraction. It's going to have a numerator and it's going to have a denominator. And in the end, all you're doing in a conversion factor, people, is multiplying by 1. Let me show you. Don't do this. Don't write this down yet, because I'm going to put the notes up in a second, but watch. If I take whatever number it is, it's just 8, and I multiply him by 4 over 4, what do I get? 8. I get the same number, right? Because what is 4 over 4? 1. All right. That's all you're doing in a conversion factor. You're multiplying by 1, because the stuff in the top is equal to the stuff in the bottom. 4 equals 4, right? And since they're both equal, they cancel out, you get a 1. Well, that's what you're going to multiply by in a conversion factor. The difference is you're going to actually, the stuff in the top and the stuff in the bottom are going to be in different units. So all you're going to do is convert the units, but they'll be the same number. In other words, 5,000 meters is the same as 5 kilometers. They're the same thing. We're basically multiplying by 1, as you'll see when I do this. Here's what your conversion factor contains. In the denominator, you're going to put the units of the given information. The units of the given information are going to be in the denominator. And the units of the required information, what you're looking for, if I'm going from kilometers to meters, are going to be in the numerator. So if I'm looking for meters, I'll put them on top. And you simply fill them in with how they're related, how they're actually equal to each other. That's it. That's the only notes I have for this first half of the class. We only have a single today, you said, right? Well, that's all we have for the notes. Now let's do a whole bunch of examples. Okay, we're going to do a whole bunch of examples here to practice these. Okay? Let's try this. First question is the same question I asked you to start the class off. You all got it right. Everybody knows how to do this. Why am I bothering to teach it to you? You'll see. How many meters are in 5 kilometers? By the way, we're leaving significant figures alone for a little bit, but you're going to find them popping right back up here pretty soon. We did significant figures for several days, labs on it and everything. They're going to be here again too, you'll see. All right, how many meters are in 5 kilometers? Let's read the steps. First step, what am I going to do, Caitlin? What am I going to write down? Which is?
5 kilometers.
Exactly. So I write down 5 kilometers. Now, the second step is to multiply by a conversion factor. Let's look at what the conversion factor has to contain. What units? Guys, I only want the units. I don't want the number. What units will go down to the bottom of the denominator? What units? What do you think, Jeremy? Kilometers. Okay, and the way you're going to remember that, people, look up here. The way you're going to remember that is what will happen to those kilometers. If I have kilometers up here and I have kilometers down there, what will happen to them? What will they do? They'll cancel. It's exactly what I want to do. I want to get rid of kilometers, and what do I want on the top? Meters. That's what I'm looking for, right? So I put meters on the top. Everybody good with that? Hannah's back. Hannah's front. Hannah's top. Hannah's bottom. Get it? Hannah's back. That's Hannah's back right there. I can see Hannah's back. Now I can see her front because she's facing me. All right. So far, so good. There's no real thinking that goes into this. This is pretty darn easy stuff, right? Here comes the only thinking spot. The only thinking part is I have to figure out how many meters are in a kilometer. And that's why, if you don't memorize these things, you're never going to get any more right this way than you would the other way. You still have to know what kilo and hecta and deca and deci and all those things mean. All right? We all do know. The one I chose earlier was kilo because you all know it. How many meters are in a kilometer? Everybody should know that. What is it? 1,000. There are 1,000 meters in 1 kilometer. So you fill it in with those two things. But that's the only thinking part because that takes all the guesswork out of everything. There's no more guesswork now. Let me explain. I no longer have to guess which way or how many places to move the decimal place. Once I write that in there, I'm told how many places. What tells me how many places I'm going to move it? What tells me how many places I'm going to move it? The zeros. 1, 2, 3. You see it? You just count up how many zeros you got, right? Second, how do you know which way you're going to move it? Well, it depends if you're multiplying or dividing by 1,000. In this case, I'm multiplying by 1,000. He's at the top. When you multiply by this number, if he's in the top, am I going to make that 5 bigger or smaller? Bigger. When you multiply by something, you make it bigger. So 5 moves 3 spaces is going to be 5,000 meters. Now notice something about this guy before I leave him alone. Does he have any more or less significant figures than that guy? No, they're the same, aren't they? Because we know the rule. We're going to cross out all those zeros, and there's only one significant figure in that. There's only one significant figure in that. You've been doing that for several days, right? Okay, good. All right. Well, I just did one. Hey, look at how long it took me to do that. I put this on the board a second ago. Well, 5 minutes ago. And you all raised your hands and gave me the right answer in a matter of a second. So why am I doing this? It's such a waste of time. I'm going to just be killing myself doing all this work when there's no reason to. Well, trust me again. You got to keep going here. A couple more we're going to do. Try this one. How many grams are in 2.4 centigrams? Now, when I ask ones that are not necessarily ones that you were familiar with. I could have asked hecta or deca or deci. You're going to start getting more wrong for a couple of reasons. I won't move it the right way, or I'll forget how many places. This will take that guesswork out, as long as you know what the prefixes mean. And there's only 6 prefixes I'm going to make you know. Only 6. Kilo, hecta, deca, deci, centi, and milli. That's it. You already probably know milli, centi, and kilo, right? Kilo's 1,000. What's milli? 1,000, a smaller, small, 1,000. And centi? 100, right? Okay, so you already know 3 of them. So all you got to do is memorize 3 other ones. All right, let's do this guy. What do I write down first here, Michael?
2.4, the given information.
Which is 2.4 centigrams. Good. Very good. 2.4 centigrams. What do I do next? What units are going to go on the bottom here, Jackson? Centigrams. Because, guys, by the way, you don't have to memorize that. How'd you know they had to go on the bottom, Caitlin?
That's the given one.
No, that's memorization. How do you know that without memorizing anything? Because they're going to have to cancel. Exactly. If you put them on the top, what would you get? You'd get centigrams squared, wouldn't you? You don't want centigrams squared. What do you want, Caitlin? You want grams, so we'll put grams at the top. Now here comes the next question. The only really thinking question. How are grams and centigrams related? What am I going to fill these guys in with? You already said you knew it. You knew that the centi means 100, So where am I going to put, which one's going to go where?
Excuse this interruption. We are continuing to call students to the auditorium for pictures. Students in homeroom
Think about it.
48, Mrs. Hubbard, room 49, Mrs. Eisenberg, and
Wait,
room
just wait.
51,
Wait till I finish this
Mrs. Pippa.
Okay, you ready?
Those should report to the auditorium at this time.
How do I fit this guy in here? What do I fill this guy in with?
Thank you.
Where's the 100 going to go? The top, he says. The numerator, he says. What do you think, Spencer? The bottom. You have to think what makes sense. Let me show you this ruler, right? Let's think about this ruler. You all know what these are called on here. These, you already measured. A couple of different labs, you used these. You didn't use this one, you used a smaller one. But these are the centimeters, right, in here, right? These are centimeters, okay? Centigrams, it doesn't really matter. Grams, meters, whatever, okay? Here's the question. We all know centi means 100. Are there 100 centimeters in 1 meter stick? Or are there 100 meter sticks in 1 centimeter? So where does the 100 go? What do you think? Michael?
Bottom.
Yes. 100 centigrams fit into 1 gram. And here's the way you'll remember that, hopefully. The larger unit will always get a 1. Because you can always fit 100 of the smaller units into 1 larger unit. All right, now once you've done that, the guesswork is done. Remember, this is the only hard part of this. The only difficult part is figuring out this step right here. Everything else before that, the centigrams going on the bottom, writing on the given information, grams at the top, everybody, it just falls into place. 1 over 100 is the only thing I have to really work on, because after that, everything falls into place. Now I know how many places am I going to move this guy? How many places am I going to move him, Brendan? 2, because I have 2 zeros, right? And which way am I going to make it bigger or smaller, since that 100's on the bottom now and I'm dividing? I make it bigger or smaller? What do you think, Sarah?
Bigger.
When you divide an apple into pieces, do the pieces get bigger or smaller? Smaller. So if it's in the bottom, I'm dividing, I'm going to make this guy smaller. So it's going to be 0.024. See, I just move it over 2 spaces, 1, 2. I just wanted to finish that one. Anybody else go on to that call? No?
Okay.
Right. Correct. Okay. All right. Well, I got one more here I definitely want to do, one that I promised you. Maybe 2 more. Let's see, 2 more. Here we go. How many seconds are in 5 years? Now, there's no way you could have done that by your old method of moving the decimal place and counting spaces, is there? You can't do that. This is the reason, the main reason I'm teaching you this method. It has very little to do with the metric system. I want you all to hear this. I know you could do the metric system faster and get just as many right by memorizing the way you used to do, just counting spaces. I know you could. But you couldn't do this problem. And you couldn't convert grams to moles to atoms, which we're going to do just next chapter. A lot of things you've never heard of, you're going to have to be able to convert from one to the other. All right, anyway, let's do this. Let's see if the same system works. What do I write down first here? Autumn. Which is? Now, by the way, start this way over to the left and write small. And there's a reason for that. 5 years. Good. Now, start way over to the left and write small because we can't, well, we can do the next step. What's going to go on the bottom of this guy, Garrett? What unit's going to go on the bottom? Years. Mine or yours? Yours. Not mine, yours. Right, years. Caitlin's still looking at me like, what the? Do you get it?
Yeah, oh yeah.
Okay, good. All right, years go on the bottom. Now, what should go on the top? Seconds, right? But does anyone know off the top of their head how many seconds are in a year?
3,600.
I don't think so.
No. It's no. That's what is that?
I don't know.
That's an hour.
It's an hour. That's an hour. Okay. That's an hour.
Okay.
Yeah.
Okay, I think you're not getting the point. The point is, most of us don't know the answer. That's the point. So, what do we know? How many what in a year?
Days.
Days. Let's go to days. I know how many days. Some of you are still in a days.
Yeah, it's an hour.
So, right. How many days are in a year? 365 days are in 1 year. Y'all agree? All right. Now, you see what I love about this system, and you'll love about it as we go on throughout the year, is that I don't have to just hit equals. I can now continue to do the same thing over and over again using units that I'm familiar with. What is going to go on the bottom? I just crossed out years. What's going to go on the bottom?
Days.
Days. All right? And do I know how many seconds are in a day again? No. Most of us, put your hand down or I'll have to hit you.
I wasn't going to read it.
It wasn't. Michael. He raised his hand. I wasn't talking to you this time. I was making fun of Michael. No, you don't want to, yeah, I do know how many hours are in a day, don't I? Right? So hours. Not mine, but all of ours. Okay. 1 day contains how many hours? 24. Okay. Now I've gotten out of days, because some of you are still in a days, and I've gotten into hours, not mine, but all of ours. And we're going to go into, well, what's going to go on the bottom this time?
Hours.
Yours? Mine. Hours. Right. Okay, hours. This is confusing. All right. Hours are on the bottom. I don't know where yours are, but hours are on the bottom. What goes at the top?
Minutes.
Yeah, I know how many minutes are in an hour. Okay, 1 hour contains 60 minutes. Now we're getting close. What do we need next?
Minutes on bottom.
Minutes on the bottom, seconds on the top. 1 minute contains 60 seconds, and then you're done. Now you don't need, yeah.
But you just do the 3,600 then.
If you are as smart as Caitlin and you know there are 3,600 in whatever, then you could do that. But I'm just showing you how you could use a series of things that are common knowledge. Everybody knows 1 minute contains 60 seconds. Everyone knows 1 hour contains 60 minutes, okay? Now, stop. That's how you would do it. You don't need to get a calculator out and do this. Because you know what? This is a very important, I'm going to make a very key statement today that you're going to hold me to for the rest of the year. I will never take off any more than 1 point on a test, worksheet, or anything for a wrong answer. Even if the problem's worth, and I'll have problems that are worth 10, 15, 20 points. You'll never lose more than 1 point. Let me show you why. All right? Watch. Say you do this, and you get your calculator out, you start plugging numbers in, 1, 5 times, blah, 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 and you accidentally hit a wrong number in there, and you get the wrong answer. That'll be a check mark, that'll be -1. But a problem like this, like in a future chapter test, which would be on maybe stoichiometry, would be, there'd be a check for this one, for this one, for this one, and for this one. And each of those would probably be worth about 2 points apiece. 2, 4, 6, 8. That will be 8 points for that, 1 point for the answer, and 1 point for significant figures. And that probably be worth about 10 points. So if you set all that up and you show me all this work, The most you'll be able to lose is 1 point. Okay? And you can hold me to that for any test question. I'm going to give you back the test. I don't know about today if we have time, but I'm going to give you back the test. Probably tomorrow you have a double. I'll have more time. I'll give it back to the other class today because they'll have a double today. You can hold me to that. When I go over those tests today, I'm going to go over and show you how I graded your short answer questions. That's where you lost most of your points. When I go give you back this test, I'm going to show you how people, there'll be multiple people who will have an A on the test and have a lot of wrong answers. All right, but they'll only have lost 1 point. So calculator errors aren't what I'm trying to correct. I'm trying to get you to get the system down right, so if you accidentally hit a wrong number on your calculator, it's not going to cost you a lot of points. So there's your third reason. I told you there were a couple of reasons to get these, to do it this way. Okay? Could I have given you partial credit if your answer is just, 5,000 kilometers? If that's what you just write down, just an answer. No, I can't. I have to see the work. And because you show me the work by this method, I will grade each step of it along the way. And that's the last reason why you want to do it this way. You want to do it because you get the right answer more often. You want to do it because we're going to use this system to do other things in the future. And you mainly want to do it, as far as practical reasons, because you'll get partial credit doing this work this way. Okay? All right, let's just do one more where I actually show you. I'm going to have to erase this one, though. Y'all go with this. Actually, you know what? I'm only going to erase the bottom here because I do need that. Okay. Copy this last one down for today. Now, I purposely chose a hard one here. It's got like hectoliters and stuff like that.
Are you not going to tell us the answer for number?
Doesn't matter. So you guys got to get out of that method. Got to get out of that mindset. Answers are the least important thing. They are. You're welcome to do that on your own if you want to. I'm never going to ask that on a test. I could care less how. I don't know who said it, but who cares? Is the best answer to how many seconds are in a year? Anthony's got the best answer to that. I don't really care how many seconds are in a year. It makes no difference to me. So you can find that answer out. It makes no difference to me at all. It will matter how many grams and centigrams are in your conversions because you're going to need them for an actual lab. But seconds in a year doesn't really mean anything to me. That's the least important part. Showing that work, that's most of the points. All right, let's do this last one, okay? And I'm going to show you how you're going to use the logic of this in this one, okay? What do I write down first, Marie?
84.2.
84.2. Again, scoot it over to the left a little bit. You're going to have to write relatively small because you're not going to be able to do this guy in one step either, okay? 84.2 milliliters I write down as my given information. Everybody go with that? All right, how about Matt? What units will have to go on the bottom? No, not at all. That's a bad answer for two reasons, but go ahead. What? Milliliters. Okay, that would be a bad answer to say hectoliters because it certainly would not go on the bottom. Now, I'm expecting that as a bad answer for the next one, but I expect that. I didn't expect it here. It should be milliliters because milliliters have to cancel. But here comes the next question. What's going to go on the top here, Nate? Absolutely not. That's another bad answer. He was out for some of it. You certainly don't rewrite the same number over again on the top. And that's not what I'm asking anyway. Am I asking what number goes on the top? I'm asking what units go on the top. All right? What units go on the top, Rupesh? But it says hectoliters. Why don't I put hectoliters on the top? Why wouldn't I go straight to hectoliters? You know what? Same reason you wouldn't go straight from years, unless you're Caitlin, straight from years to seconds. And even if you were Caitlin, you got it wrong anyway.
I didn't mean to do that.
I'm just kidding. It's okay. You don't know. No one besides Rain Man knows how many seconds are in a year. And just like most of you don't know how many milliliters are in a hectoliter. But you do know how many milliliters are in a what? A liter. So I'll put a liter on top. 1 liter contains 1,000 milliliters. See it? You say, well, that doesn't give me the answer. You're right. It doesn't give me the answer. It doesn't give you the answer. But it gets me closer. Just like converting years to days got me closer to the answer, right? Let's do another one. Now, what has to go on the bottom now? Liters. You might say, I'm your leader. I'm your fearless leader. Leader. Drum roll, please. Okay, liters go to the bottom, and what's going to go on top? What am I looking for now? Anyone? Bueller? Hectoliters, yeah. All right, now, the thing is, you guys don't really know hecto very much. All right, I'm going to kind of, in a minute, I'm going to put your, what you need to know, like all the prefixes you need to know in a second. You can write them down underneath your notes, too. Okay, but I'll tell you right now, 1 hectoliter contains, hecto means 100 liters. Okay? Hecto means 100. Deca, what do you think deca means? I heard 1,000. Definitely not 1,000. 10. Deca, you know, for the like, geometry even. All right. Almost done. Now I told you, that's the hard part. Okay? Even if they called you, just wait. That's the hard part, but this comes now the easy part again. Does she really have to say them all twice? Really? Really? Okay. The guesswork is now gone. How many places will I move, and what do I do to get the number of places?
5.
1, 2, 3, 4, 5. Count the zeros. Right, correct. And will I make this guy bigger or smaller? Smaller, because these are being divided. They're in the bottom. You all know that, a fraction, right? If you're multiplying by a fraction, and the denominator, right, is going to make it smaller. If the number's in the bottom, it's going to make it small. So it's 5 places smaller, which makes this guy 0.00842 hectoliters. 0.000842 hectoliters. Got it? All right. Now I'm going to just show you right now underneath somewhere. These are the actual prefixes you have to know. You ready? You have to know kilo, hecto, deca. Then there's the base unit, whatever that is, grams, liters, meters, whatever. Deci, centi, and milli. 2 L's milli? Or just 1? I think it's 2. And the abbreviation for each of those, I'll give you also. But what they basically mean is this. Kilo is 1,000, hecto is 100, deca is 10. Deci is 10, 1/10, 100, and 1,000. But I don't want you to put 1 over it. Just put that, because you'll never have to use a fraction doing it this way, as far as like a decimal. You could just use 10, 100, or 1,000 everywhere you want to go. Okay? Now, so those are the ones you have to know. The abbreviation for each of those, you can write to the side over here. K for kilo, H for hecto, DA for deca, D for deci, C for centi, and M for milli. Those are the abbreviations. Those are the only 6. Now, there are a lot of other ones, guys. You people who are into computers, you could tell me quite a few other prefixes that you're very familiar with. Almost everybody is. What are some other prefixes? Giga, mega, terabytes now. They have hard drives in. Okay, so I mean, I'm not going to make you know any of those. You only have to know these 6. Okay? Because generally don't deal with numbers that big or that small. There's also nano for very small, and pico and stuff like that. You don't really have to know any of those from me. All right? Now let's go back a second. One more time before I finish up here. Notice I never used anything but either a 10 or 100 or 1,000. Okay? The question is whether it's on the bottom or if it's on the top. I already erased that on the board. But remember the other one I did from kilometers to meters looked like this. Watch. It was, erase this one. 5 kilometers. Don't have to write it down. You already have it. Meters on the top. 1 kilometer contains 1,000 meters. So you're never going to use anything but 1,000 or 10 or 100. It's just a question of where you put it. And the question of where you put it has to do with common sense. Can I fit, let's look at it again. Can I fit 1,000 meters into 1 kilometer? This is a meter. This is a meter, right? And you know, a kilometer is about as big as a mile, right? Does it make sense that 1,000 of these would fit into a mile? Yeah. But if you did it backwards, You should know it by common sense. If you put 1,000 kilometers and 1 meter, you're saying that you can fit 1,000 miles into this thing, right? And that won't fit. Okay? So that you have to use common sense. All right, that would be wrong. All right, there was something else I was going to tell you about that too, but I forgot. Oh yeah. Last thing I want to say. Some of you are going to look at the examples, and they're going to see, a 1 next on the bottom here, and they'll say, okay, I'll ask you, I'll come around while you're working on an answer, and I'll say, why'd you put a 1 down there? Well, that's what you had in my example. Did I ever say at any point here that the 1,000 always goes on top, or the 1 always goes on the bottom? No. If you look, here, the 1,000 is on top and a 1 is on the bottom. Let's look at the other one. Here, 100's on the bottom and a 1's on the top. It depends. It totally depends on the common sense. You have to use your head. All right, good enough. Now, look at, what time is this over? 22. Yeah. I want you to start. There's not a lot of homework here. There's only 2 problems, and you only have to do A through C on each of them. So there's only 6 total to do, and that's not very much. Start those right now. Tomorrow we'll do something else and give you a worksheet on this to practice it a little bit more too.
You did